I want you to start by solving a couple of systems algebraically. These will be similar to the problem we worked on in class today. So let's take a look at number 1 here. We have two equations, y equals x minus 6 and y equals 12 minus x, and we're told that they're in a system together, which means that there's one point on the graph, and let's take a look at what the graph will look like, where these two lines intersect, and we're looking for that point. This line has a slope of 1 and a y-intercept of -6, so it appears on the xy coordinate grid like this. And I'm going to rewrite this equation as y equals -x plus 12. Its y-intercept is the point 0, 12, and it has a slope of -1. So we're looking for this point. We now have an idea of where it might appear on the graph, although notice that my scales are not accurate, so we're going to trust the algebraic solution more than we trust this graphical solution because I haven't drawn the x and y axis to scale. So using the equation y equals x minus 6 and y equals -x plus 12, and the idea that the y's have to be the same at this point. At this point, the x is the same and the y is the same on both equations. So if that's true, then this value here, x minus 6, equals this expression here, -x plus 12. Add x to both sides. 2x minus 6 equals 12. Add 6 to both sides using the addition property of equality. 2x equals 18. Divide both sides by 2. X equals 9. So we now know the x coordinate for the point where these two lines intersect. We need to go back and find the y coordinate, and we can do that with either of these original equations. If we know that x is 9, we can use it in place of x in either equation to find y. Y equals 3. Let's try it in the other equation. Y equals negative, substitute 9, plus 12. Y equals 3 no matter how we use it. So we have a solution of 9, 3. And 9, 3 will make each of these equations from the system a true statement. So 9 equals 3 equals 9 minus 6 is the substitution that gives us a true statement for equation number 1. 3 equals 12 minus 9 is the substitution that gives us a true statement in equation number 2. And that idea that you can solve a system of equations algebraically can be used with trig equations as well as it can be used algebraically. So let's take a look at how that concept that should be reviewed from your algebra class can be applied to the problem with the balcony when we know the distance from here to here is 6.2. So let's draw the situation as you had it on the board today. You have a 19-degree angle here. This whole angle is 29 degrees. These are two right triangles that are nested within each other, and we know that this distance right here is 6.2 6.3. And that's measured in meters, and it's directly above this measure here, which is unknown, and this measure here, which is unknown. So if we draw the triangle separately, here's our triangle with a 19-degree angle, our right triangle with a 19-degree angle, and here's our right triangle with a 29-degree angle. The height for the 29-degree triangle is 6.3 plus y. Using the tangent ratio with each of these, we can come up with two equations that will be in system together, just like the algebraic problem we just solved. Tangent of 19 equals y over x. Tangent of 29 equals 6.3 plus y over x. That's the opposite over the adjacent in both cases. If we multiply both sides by x, we have an equation x tangent 19 equals y. And we can do the same thing here to cancel the denominator. X tangent 29 equals 6.3 plus y. We can solve each of these for y. X tangent 29 minus 6.3 equals y, and x tangent 19 equals y. We know the y's are going to be the same because this distance hasn't changed. It's the same for either triangle. So x tangent 19 equals x tangent 29 minus 6.3. If we subtract this value, x tangent 29, we have both of our x terms on the left-hand side of the equation, which allows you to factor and when you factor x out of both of these expressions, you have x times the quantity tangent 19 minus tangent 29 equals negative 6.3. And this is a value that your calculator can find for you. It is also a value that can be divided away on both sides. So this expression, tangent 19 minus tangent 29, represents a number. So x is equal to the value of 6.3 divided by tangent 19 minus tangent 29. So using enough parentheses, calculate that. So after you hit the division symbol, start a set of parentheses. Once you hit tangent 19, your calculator is going to open another set. So push those buttons and see what happens. Close the parentheses after 19, close the parentheses after 29, and then close up the whole denominator in its own set of parentheses. And you'll have a value that's approximately equal to 30, I believe. Let's see. Yep, approximately equal to 30. Go back up to your diagram. And that gives you your distance along the horizon, which is enough information to go back and find this distance y using either of your equations. So x tangent 19 equals y. Using substitution becomes 30 tangent 19 equals y. Making that y distance approximately 10.33.